So I'm going to move on to problem 4 from midterm number 1, and we're going to see what my solutions were, what I came up with. And in this case, actually, most of my solutions were pretty similar to the provided ones. As usual, let me go ahead and import these first few blocks, evaluate them. We're not doing any work yet. We can read through them. We've got our excerpts, that's fine. And we get to our first thing, which is we have to normalize the text. And as usual, what they want us to do is go ahead and convert everything to lowercase, get rid of anything that's not a space or just text. So in this case, well, let's see, the way I'm going to do that, keep this very straightforward. I'm going to go ahead and take our text and convert it to the lowercase. So that's our first step. Now I need to have my results, and this is where mine is a little bit different than theirs. Now I need to go through and check the text, and if it's an alpha character or if it's a space, then I'm going to keep it. So for every character inside the text, if C is alpha or C is space, well then, go ahead and put it into our result, and let's return our result. And double check my spelling because that's where I've been getting things wrong here. And of course we have this long test, but it passed. Now the solution they provided was basically just a little bit shorter. They managed to do all of this in a single line of text because you can do that. But by doing the nested commands myself, I like to break it apart, especially when I'm solving a problem. I like to break it down step by step. I'll worry about making the code nice and pretty later. If something goes wrong and I've solved it this way, I only have to worry about a single step at a time. So that's the reason I did this. All right, let's come on down to our next section. Complete the function clean excerpts, which takes in a list of strings and returns a list of normalized strings. Okay, this isn't too bad. We just want to normalize each string they give me in a list. So first thing is I'm going to give them back a list. So I'm going to go ahead and set them back to give them back a list. And for each element in the excerpts, for everything they give me, let's go ahead and append into our results. We'll clean the text. We're just going to use the function that we just got done writing. And that's it. As I recall, the provided solution again takes this code, insert into a single line of code. I just like doing it this way again because it helps me make sure I'm doing everything right. It cleans it, tests to make sure it cleaned properly, it cleaned properly. So now we get down to bag of words. Now bag of words where you get a little bit different now. Not too much different, but a little bit. We'll evaluate this. We have stop words. It says program those in, so we know the stop words. We're not going to use those. Okay. So we're going to find the similarity between two documents. We use a bag of words model. We're looking to see how many words they have in common, how often they're using the same words. Definitely read their Wikipedia. There's been a lot of stuff done on this. If you get interested in how some of the websites use to detect cheating, they've used models much more advanced than this, but models similar to this to see if two authors have a similar enough style, but they're supposed to be different authors. So interesting stuff to get into. Definitely is a real world application. Exercise 1A, I'm going to do an extract words, which is just going to, you give me a bunch of words, I pull them out, how often they come up, so I need the list. No stop words allowed inside of it, so that's not that bad. My answer, again, is not that different from theirs, but like I said, I keep things nice and straightforward. First thing is, I'm going to go ahead and take the words they gave me, and I'm going to split them into the individual words that are in there. So I have a list of words in the document they gave me. Now I have as a list instead of one long text string. Okay. Now my actual results, I need to have them ready. So I'll have that list ready to go. And now for every word that's in my original result, if it's not a word in stop words, so if it's not in stop words, let's go ahead and put it inside the real result. So if the word does not appear in stop words, put it inside the results, And let's return those results. Again, I just like doing this one step at a time, keep it nice and simple. In fact, I believe, again, all they did here was they combined this into a single line of code. In fact, it was where they did, here was the line of code they used. That's my for loop. Just in a single line of code. I'd rather keep my for loops so I know I'm doing things right. Evaluate that so it's programmed in. Let's test it. It passed. Now I need to keep a vocabulary for different books. Okay. So this one's not that bad. My books complete the function. It takes a list of documents, returns a vocabulary of unique words for that data set. And it should be sorted in order. That's not much at all. So let's get our result list ready. Now for every item that's inside of my list of documents, let's go ahead and iterate. Make sure I spell this right. Let's extract the words from that item. I'm going to call that iterate. And the reason I do that is for each word in iterate, I need to go ahead and put that into my result. Okay. So now I have that, except first thing is I need to make sure I don't have words repeatedly. So it needs to be a list, but the way I make sure I don't have the same word repeatedly is convert my original to a set. So now I'm going to take the result I had, convert to a set, so each word only appears once, and then cast it back into a list because I need it to be a list when I return it. And of course, last thing, let's go ahead and sort that. So now it'll be in lexicographical order and return the results. Whoa, spell that right. If we test it, oh, I have an error. What did I do wrong? Let's look. There was a typo somewhere for item and list of documents. Well, let's see what it tells me. Assert. Create vocab failed on create 10 different sounds. Create 10. Oh, there's some error happened here. Where do I have the... Oh! My indentations. Let's get those back where they belong. It's so easy to make those mistakes. And there it is. Okay. Okay, 1C, I get a list of documents, vocabulary, create a bag of words vector for each document. So now I'm going to go ahead and take the document, take the words. They need to maintain the order and just get a vector of each one. So this one isn't that bad. Okay. So first thing is, I need to think about how long should my vector be? Well, my vector, its length should be equal to the length of the vocab they give me. This way I make sure my vector will always be the appropriate length, so I don't end up making a mistake and sending back a vector that's missing an entry. So I'm going to use that. And of course, have my result. And what I'm going to do is for every document that's in my document list, that what I need to do is my row, I'm going to start off with a blank row that's equal to my row. Let me see how to phrase this. My vector is a row in this case. And each of those needs to be appropriate length. So I'm going to instantiate that vector to be the appropriate length. This way I don't have to worry about if I'm putting a value somewhere and I haven't actually set a value there. So I instantiate my vector as a 0 vector of the appropriate length. Now, I need to store some words temporarily. And what I'm going to do is pull the words out of the document. So I'm going to extract words from the document. I'm just going to store them temporarily. Because now for every word in my temp words, I need to find out where it belongs. So let's place it. Well, let's see. Where in vocabulary is that word? So if I pull the index of vocab, it's going to look up where that word came from. So now I can get the index of that particular word and get its index. And since I know that, and I stored its location and place it, well, now I just need to increment that entry by 1. Oh, I forgot a square bracket there. So what it's doing is it's taking my vector that I created here. So here's my vector. It's a 0 vector with nothing in it. I pull all the words out of the document. And then what I do is I go over each word. And what I do is I look inside of the vocab that they sent me for that word. And that's what I'm doing here. Except I want the index. Where is that word in the vocab vector? And save that index location as place it. Now in my vector, row, go to that index and replace it instead with, well, what value was in the row, and increment it by 1. Because what index does, and this way I'll get my vector. And of course, let's go ahead now and put that inside of our results and then return the results. Because once it iterates through each document, we'll have all the vectors. That'll be it. Oh, got an error. Probably have something spelled wrong. Let's see. Extract words is not defined. Because there's supposed to be an underscore. And that's it. So bag of words 2, this is just another test cell. It's a hidden test case. Yes, it passes it. So I'm not going to stay on that real long. There's no need to. Okay, so come down here. It's going to do some other bag of words on Gatsby and 1984 and all those. So those have now been done. And now I want to normalize. Now I'm not going to go over what all this means, the mathematics here. I want us to get to a certain point, but we want to normalize each vector. So this is very straightforward. First thing is we've already imported math, so I don't need to import it again. At the very top, you remember we imported math when we began. Okay. Now it should be returning a list of vectors. As soon as I see I'm returning a list of vectors, I instantiate a list. Now the only question is, how long should it be? Well, it's equal to the length of the bag of words of the first entry. So however long that bag of words is, now I know how long it should be. And now for row in bow, because I'm going to treat each entry as its own row, so I'm going to call it a row right away. I need a new row, and that's going to be equal to a copy of the row. So I've made a copy of it now. And what I want to do is I want to iterate over that row. Okay, so I'll be able to iterate over this way. And now inside of the new row, in each place, what I want to do is square the value that's already there. So, and again, I'm just putting the formula in exactly like they gave it to me. I'm just implementing over it. Once I've done that, well, the base of that formula, I need to back that up. Let's see. Yep, I've got that right space. Well, that's equal to math dot square root. And the square root, well, the sum of the new row. So all I'm doing is typing in this formula, incrementing it just one step at a time. And yes, you probably do this much faster by using more of the math commands. This to me is just another way to do it. I'm just taking it one step at a time. Now, I have my result row. This is equal to a list. Let's get that spelled right. We'll call it result row. And for every entry in my bag of words, so I do my for loop again. Well, let's go ahead and put in what we just found. So now we can go ahead and do that division, put it in there, and we'll have normalized our vector. Well, scroll too far, sorry about that. And that is what actually goes into our results. And I use the result row again here, even though at this point now, it's just going to be a single number instead of a list again. And of course, now we can return our results. And yep, I did something wrong. Let's see where I typed something in wrong. For row and bow, new row gets a row copy. We're going to iterate over that new row. Okay. The base is equal to the square root of the sum of the new row. Result row is a blank list. Oh, I said bow. That's supposed to be row. And yeah, row, bow. Gotta be careful with spelling. Throw you off right away. So we passed. Now, finally getting down to where things get actually a little bit interesting. So we see how sparse they are. They're pretty sparse. So keep working. Now we have our inner product. So before I get too far in this, something about the inner product is if you remember this, it actually will save us some time later on. Inner product, remember if I have two vectors, if it's the same vector, so if I take the inner product of a vector with itself, I'm going to get 1. The closer something is, so if I have two vectors that are also very similar, they have a very small theta between them, very small angle between them, their value will be closer to 1. The more further apart they are to being perpendicular or orthogonal, we're going to get a 0 because of the cosine of the angle between them. So we're going to remember that. So in this case, our first case is just what's the inner product between two vectors? And I'm going to be honest with you, I don't like to reinvent the wheel. NumPy does inner product. So we're going to import NumPy as NP. And then my result is just a float of the inner product. And then I have to cast each as an array. And that'll be it. NumPy will have done the inner product for me. I don't need to do it manually by iterating over the list. NumPy knows how to do an inner product. I'm not going to reinvent the wheel. It works. Now we're going to look for the most similar. So they're going to give me a list of n bows, of normalized bows, and the target. And what we want to say is what is it most similar to? So in this case, this is where I brought up about inner products, that if you take an inner product to itself, you're going to get 1. The closer we get to 1, the more similar two things are. So I want to find the inner product of the different n bows and the targets in order to figure out which one is most like it. So let's go ahead and pull up our comparisons. We'll make a list for saving them. For every entry, we're going to save this. Oh. So now I'll be able to iterate over it, but I want that I need a number so I can use it as an index. Now catch is, if that index happens to be the target, I don't want it to do the inner product with itself, because if it does, it's going to come back with 1. And my idea already is when I want to say two things are most similar, I'm looking for the maximum value. Well, if I cross something, if I do the inner product with itself, that's going to be the maximum value. So instead I'm going to override it. I don't want it to do it. Instead, I want to make sure I don't accidentally call that. And I'm going to go ahead and put in the value 0. Because I don't want to say, yes, of course this is it. It happened to be itself. So if it does come up to a point that is comparing it to itself, go ahead and put in a value 0. Do not compute an inner product. And this will avoid that problem of saying, oh, I found what's most similar to. Yeah, you compared something to itself. And that's not going to work. So now instead, we're going to look at what we do need to actually have added. And that is the inner product. That's the function we used before. And it's n bows. And compare it to the target. And we'll get the inner product of each n bows as we go to the target. And we want to see which one's most similar to it. And of course, add those to it. Now, all we need is to find out which one of those is a maximum. So the maximum position happens to be equal to the index of the max of comps. So it's going to go through comps, find the maximum value, and then it's going to give me the index of where that happens. And that's what I need to return. That's the one that's going to be most similar. But the trick on this that saved me a lot of time was this. I knew an inner product, if you do an inner product of a vector with itself, you get 1. I didn't want that to happen, so just in case it was going to, I overrode the system and said, nope, put in 0. And that'll be it. Rerun it. Kind of error. I'll bet you it's a typo. Let me see. Comps is a blank list. Oh, what did I do wrong? Okay. Oh, append. Such a simple mistake. And there they are. And that was it. Now, whether or not this works, how well it holds up, I don't know. Pride and Prejudice is most similar to Hamlet. I guess so. Both old books. I guess it could be. So that was my solution for problem number 4. It was not identical. There was definitely some differences. The way I solved most similar was definitely different from how they solved most similar. To me, I thought this was an easier one. It just took into account the fact that I knew how inner products work. So if you had a problem, you were solving it in the same kind of way, and got stuck, I hope this helped you out. Or just give you a different way of seeing it. So have a good evening.